In most applications, it's a good idea to handle exceptions, even if they're not expected to happen. Most exceptions and problems occur because they're unexpected. How about if we'd like to execute code when there's a successful execution of our asynchronous operation and not execute it if there was a problem? In our code that loads the file from disk, when we change the file name to a non-existing file, and when we try to open that and read the lines, an exception will be thrown. If that happens, it's unnecessary to run the following continuation, which handles the parsing and populating the data grid. If we execute the application with the debugger attached and try to load a file that doesn't exist, we can see that the task inside the continuation is in a fault state. The promise of a continuation is to be executed once an asynchronous operation is completed. With the task and the continuation introduced with continue with, it will do so no matter if it was a successful operation or not. The anonymous method requests the completed task to be passed into it, and upon inspection you can see that the task has an attached exception. The inner exception indicates that it couldn't load the file. Since we are using the task parallel library and not using async and await, the exception that we get here is an aggregate exception. This means to get any valuable information out of the exception on this particular task, you have to look at the inner exception. You will see that it will continue to execute the next continuation as well. In the final continuation, we don't capture the task, and all that is doing is updating the UI. If we were to attach another continuation onto the task that's now updating the UI, the task passed into that wouldn't in fact be a fault state, because the previous task that it's continuing from did so successfully. So now you are probably wondering if there's a way for us to indicate that we only want to execute this code when the previous operation that we're continuing from completed successfully, without any exceptions. When creating the continuation, there's something called continuation options. It allows you to specify the behaviors to the scheduler for when to execute this continuation. You could say that you should only execute this continuation when the status of the task it's continuing from is not faulted. We could also simply say that we want to execute this when the task ran to completion, meaning there were no exceptions. If we specify that this should be executed if the task we are continuing from ran to completion, it will only execute the continuation if the task has no exceptions and was not cancelled. Running this again with the debugger, you'll see that it skips the continuation, which is marked as only to be executed when the task ran to completion. How about if we'd like to add a continuation that handles exceptions? If you just append another continue with at the end of the method chain here, you'd probably not get the result you expect. The task passed into the continuation would be the wrong task, as it would point to the task which represents the previous continuation. That's not our intent. Our goal is to add a continuation that handles exceptions when the task that processes our lines is in a fault state. Don't worry, the final continuation will execute no matter if the previous task was executed. This will ensure that the loading indicator is always removed from the UI. If we explore the task continuation options, we could use only unfaulted or not on ran to completion. Let's go with only unfaulted for now. There's no specific continuation that adds a note to the application with the message of the inner exception. This will only execute if there was a problem completing the task. You could have multiple continuations attached to a task that runs for the particular purpose. You could control if one or more of these would execute depending on different scenarios using the task continuation options. The notes are now updated to say that it couldn't find the file we are looking for, obviously because the file doesn't exist. And with very minimum effort, we chained on a continuation that the scheduler will only execute if the task it's processing faulted. This allows us to have multiple different continuations that matches the expected outcome of the asynchronous operation. Prior to the async and await keywords, this was a much more common approach. And there's nothing stopping you from combining the two. As an example, let's say that you want to log the completion of a task. You could simply chain on a continuation with continue with, and to conform with the same method signature that you might expecting, you can return the value that was passed into the continuation. That way, it returns the same type of task with a given result that you previously expected. So this won't change the method signature or how the consumer awaits the task that is returned. They won't even know that it executed this continuation. A big difference is that the exceptions in the continuation of continue with will contain an aggregate exception. With the await, it doesn't give you an aggregate exception, thus you don't have to inspect the inner exception to get any valuable information out of that. I'd always recommend that you'd use async and await, especially to validate that your tasks have completed successfully, so you will be able to catch potential exceptions. This will also give you the cleanest code. If you already have multiple different continuations in your project, and you want to make sure that one of them is only executed when there's a problem, or when there's no problem, you could use the task continuation options. Remember that continue with also returns a task and runs asynchronously. If there's a problem in the code, it'll throw an exception, and then it will execute the next continuation in line. You've now seen how to introduce a chain of tasks, where some will be executed upon exceptions, and some only when everything completed successfully. No matter if you're using async and await or the task parallel library with continue with, make sure that you validate your tasks and your asynchronous operations. It's definitely important to also validate the continuations, because none of us wants unexpected behaviors in our applications. You can now handle the success or failure by either using async and await or the task parallel library. This is something every developer should be doing when introducing asynchronous code in their applications. Next up, we'll be talking about canceling a task, which may sound a lot simpler than it actually is.